So this is what was labeled day 9 homework. This is practice 5-4. And it's just a review of factoring, doing some more practice problems. So I wanted to give you an overview of like what all the types of factoring were. Okay, so starting off, I'm going to do the easiest kind, which is located in number 1. Now, all of the circled problems here, I'll try to at least talk about a little bit. Okay, so that first one, number 1, x squared plus 4x plus 4. I'll write the answer over on this side though. Okay, so number 1, x squared plus 4x plus 4. So again, check for a common factor everywhere. Any number letter that goes into all 3 parts, there is none. So then next thing we want to do, multiply your first and last terms together. So that's a 1 times a 4. What 2 numbers multiply to give you 4, but add to give you 4? Okay, so hopefully you start to get a little better at these, but you'll realize that it's a positive 2 times a positive 2. So that's going to give you as a solution x plus 2 and x plus 2. Okay, no need to divide and slide because your leading term was 1, and so we're actually done with this one. We can move it out of the way and move on to our next problem. Okay, so the next one, number 4, a nice tricky one. Okay, pause the video in a second and see, can you factor that one out? Think of how you might want to do it. Okay, so you pause the video, think about it, and unpause it if you can't figure it out. Okay, so remember, the first thing we're always supposed to check for is a common factor everywhere. Well, this has a 1 in front, so then as far as numbers goes, there's no numerical common factor, but there is a variable common factor. You notice that both of these have an x to some power in it. Okay, the first one's x to the second. The second one is x to the first power. So if we would factor out that x, okay, there's only 1 in the second one, so we can only take 1 away from everywhere. You're going to be left with what's there when you take away one of the powers of x. So x squared goes down to a single x. And then this second one, x to the 1, we're taking away one of those x's. So there's no x left there, and so we're just left with x minus 6. Okay, now there's nothing else to do because that was all that needed to be factored. So we're done with that one now. Okay, going on to number 10. Number 10, you may be tempted to think, oh, it's the exact same way. It's actually a slightly different kind. So this kind is called a difference of squares, and I'll show you the long way, and then I'll show you the short way. Okay, so a difference of squares is because the first term is a perfect square, it's x squared, and the second term is also a perfect square. 4 is the same thing as 2 squared. Okay, it's a difference because of the minus sign in between. Okay, so the difference of squares. Well, one way we could do it is just think, okay, so our last term is negative 4, and our term in the middle is what's multiplying x. Now, since you don't see an x there, there's actually a 0x. Okay, so when there's nothing there, well, what 2 numbers multiply to give me negative 4, but add up to give me 0? So in this situation, if 2 numbers are going to add up to give you 0, they have to be the same number but opposite signs. In this case, positive and negative 2. Okay, well, that brings you to your solution. It's going to be x plus 2 and x minus 2. Okay, now I said there's an easy way and there's a harder way. Okay, that was the harder way. The easy way for this one, if you can remember, it's pretty simple. So this always is going to factor into the square root of the first part plus and minus the square root of the second part. So the square root of x squared is x. The square root of 4 is 2. And so again, it's x plus 2, x minus 2. So that tends to make it a lot easier. Okay, so that is your next problem. Okay, we're going to be moving on then to numbers 16 and 19. So 16 and 19 are also differences of squares. Okay, so it may be interesting for you to try to go ahead and start thinking about that a little bit. Okay, so 16 and 19. So 16, I'll write it over on the left closer to the problem. 16, remember, we can say it's the square root of the first part plus and minus the square root of the second part. Well, how did I know it was going to be a difference of squares? Well, one thing is that I have this perfect squares up to 10 squared memorized, and I recognize them. So like 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on, and you can go all the way up. Or you just notice that when there's no x term in the middle, like all these other ones have linear terms, the 1x, the 2x, the 3x, and so on in the middle. Okay, for ones that don't have that term, then it may be an indication it's a difference of squares. Well, this is going to be x minus the square root of 64, which is 8, and x plus the square root of 64. Okay, your next one, what's the square root of 36? Okay, the square root of 36, the number that multiplies itself to give you 36 is 6. So that's going to be x minus 6 and also x plus 6. Okay, so we have 3 more to work through. Numbers 36, numbers 38, and numbers 51. Okay, 36, 38, 51. I'm going to erase some of these old ones. You can always go back in the video if you still need to see them. Okay, so number 36 gives you a 2x squared plus 13x plus 15. Okay, we need to go back to the headphones, so the method from day 8 video that's uploaded already. So 2 times 15 gives you your top number of 30. Now we need two numbers which multiply to give us 30 and add to give us 13. So you may need to think through that a little bit. Well, you can start with 1. 1 times what is 30? 1 times 30 is 30. But 1 plus 30 is 31, so that doesn't work. 2 times 15 is 30. 2 plus 15 is 17 though, so that one doesn't work. 3 times 10. 3 times 10 is 30. But 3 plus 10 is 13. And that is actually what we wanted. Okay? So we're good there. So write in a plus 3 and a plus 10. Well, that gives us x plus 3 and x plus 10. Now, this is the divide and slide method, because now we need to divide by our leading term, 2. If it divides, like 10 divided by 2 does, you can go ahead and divide it. So it gives you x plus 5. X plus 3 over 2, 3 divided by 2 does not work, nor does it reduce, so slide your 2 in front, and so that gives you 2x plus 3. Okay, number 38. 3x squared plus 16x plus 21. Harder because of large numbers. So the headphones method, 3 times 21 gives you 63. Okay, 16 positive goes on the bottom. So try to think of your numbers which are going to work. What two numbers multiply to give you 63, add to give you 16? So start. 1 times 63 is 63, but adding them does not work. 2 can't multiply in it. 3 times 21 works, but 3 plus 21 does not. 4 doesn't multiply in. 5 doesn't multiply in. 6 doesn't multiply in. But 7 does, and it's 7 times 9. Because adding them together, 7 plus 9 gives you 16. Okay, so that's going to be x plus 7, x plus 9. And now when you divide by your leading term, you will get the correct answers. So divide them both by 3. The second one actually divides, x plus 3. The first one does not, nor does it reduce, so you get 3x plus 7. Okay, lastly, number 51. Okay, so number 51 gives you 10x squared minus 17x plus 3. No common factor. Do the headphones. 10 times 3 is 30. On the bottom, negative 17. Okay, so what two numbers multiply to give you 30? Well, 1 and 30, 2 and 15, 3 and 10, 5 and 6. Okay, which one of those add up to give you this negative 17? The closest we have is 2 and 15. Okay, but those add up to give you a positive 17. Keep in mind from last video, when that happens, we can change the sign of both of them, because still the multiplication will work for the positive, and now the addition will work for the negative. Okay, so we're going to have a little tougher time with divide and slide for this one. X minus 2, x minus 15. You can divide them both by 10. Now, neither one of these actually divides, but both of them reduce. So the first one divides by 2, top and bottom. The second one divides by 5, top and bottom. So we're going to get x minus 1 over 5, x minus 3 over 2. Okay, now slide the denominator for both of them. This is going to be 5x minus 1 and 2x minus 3. Okay, let's actually look at 67 as well. That'll be our last one. So number 67 has an interesting situation. What I want to point out to you is don't forget to do your very first step. Your very first step is supposed to be checking for a greatest common factor. Now the greatest common factor here is 2. So what are we going to get when we factor that out? Well, 2 divided by 2 for this 2x squared gives us a 1x squared now. 10 divided by 2 in the middle gives us a negative 5x. 28 divided by 2 gives us a minus 14. Okay, now you need to do big X with those numbers. What's inside? Ignore that 2 that's in front, but keep it there for each step and copy it down. Okay, so negative 14 up top, negative 5 on the bottom. What two numbers work? Think about it. But it's negative 7, positive 2. So now copy that 2 down. Now we're going to break up our one big parentheses into two smaller ones with those two factors, x minus 7, x plus 2. Now if you wanted to try doing divide and slide, you could, but remember, we're basing it off of this. So don't divide them both by 2. We're basing it off of this x squared right there. It's a 1x squared, so you're not going to divide anything. So this right here is your final answer. Okay, well, now pick and choose through some of the rest of these. See if you can work out this factoring. Factoring is a very, very important skill in every future math class that you have. You've covered it a couple times in Math 1 and in Math 2, but try to master it.